Hello, I'm Michelle Davis of the Center for Manufacturing Research at Tennessee Tech University in Cookeville, Tennessee. Welcome to the Spring 2019 Golden Eagle Additively Innovative Virtual Lecture Series. This is the 7th semester we have produced this popular and informative series. The series is hosted by TTU's Center for Manufacturing Research and the iMaker Space at TTU. The CMR is recognized as an accomplished center of excellence that draws together resources of the state of Tennessee, the university, industries, and government funding agencies into a cooperative effort to be on the leading edge of the latest technological advances in the manufacturing field. The iMaker Space, located in the Volpe Library on Tennessee Tech's campus, has the goal of providing an interactive and collaborative space for students and faculty to use in pursuit of innovative and entrepreneurial projects. Additive manufacturing is a focus of both entities, and as such, this short virtual lecture series has been planned to highlight the best practices, potential problems, technological advancements, innovations, and scientific contributions in additive manufacturing, with expert talks from various institutions, industries, R&D centers, and laboratories. Today, we are honored to hear from Adam Wills of the Tennessee College of Applied Technology in Nashville. His talk is titled, Preparing Your Model for 3D Printing. The speaker will provide his contact information for questions after the presentation is over. Thank you, and I turn the presentation over to Adam.
Thank you, Michelle. As Michelle said, I teach computer-aided design at a College of Applied Technology. And the Colleges of Applied Technology, we focus on foundational learning for our students so that they can build a career in this field of computer-aided design. And so today I want to talk to you about how we prepare a model to be 3D printed. It may be information that a lot of you know, but there's always someone that's just starting out. So let's begin. One of the first things we should do when we're talking about preparing a model for three-dimensional printing is decide whether we're going to draw a solid model or we're going to draw a surface model. The surface models, there's a lot of uses for surface models. People use that developing avatars for video games and the like. But surface models are almost always, almost always have openings in the mesh. They're said to not be watertight, in other words. And we need a watertight model if we're going to successfully create a 3D print. Where are you? Why is it not working? There we go. This slide will show you that surface models, they are hollow. We're by definition modeling just the surface, and so it won't have any of the internal structures that so many of us are fascinated by when we see our 3D printers produce those internal structures. Solid model, on the other hand, has intricate and elaborate, can have intricate and elaborate internal structures, and so we can use them in various assemblies for manufacturing and the like. Surface modeling, again, it has its uses, but for 3D printing, I prefer solid models. We have 10 3D printers in our lab. I have 4 different slicing softwares, and so we always use the solid models when we create our prints for 3D printing. The next thing that we want to talk about is the file format that you should use when you're doing 3D printing. Now, there are other file formats other than STL, but the STL is by far the most reliable that we have found for solid modeling translation into our slicing softwares. The slicing softwares will sometimes accept object files or other 3D printing files, but we find that that always the STL is accepted and most reliable. Some people translate STL into stereolithography. Generally we like to say STL is the standard tessellization language, and so it stores the vectors and the normals that we have that we have to use when we bring a model into a slicing software. When we export an STL from our solid modeling software, we have a lot of different options that we can use to help produce a better quality part in our 3D printers. And this is something that that my students learn as they learn to produce solid models. They have to know how to manage those software options to produce a really good quality STL. If we look at the examples in this slide, we see that the one on the left, the cylinder is faceted, which, you know, it's just not smooth. And what we want is a nice smooth cylinder on the right. These models were created in AutoCAD. And in AutoCAD, the command that you would use for smoothing your solid model is facet res. The one on the left, the model on the left, is the minimum resolution. The one on the right is the highest resolution for that command. Most people will use a parametric solid modeler, but occasionally I will use AutoCAD when I'm doing more artistic models. This is if you can see here, the two models are brought into a slicing software. The faceting of the cylinders is going to show up in your slicing software if you don't properly prepare your STL. And so, and there's nothing your slicing software can do to clear that up very well. Your model just will not be smooth. So we have to learn those options and learn how to make a smooth STL. Parametric solid modeling is by far the most widely used way to create these solid models. And so, you know, there's a lot of different softwares, and they all have subtle differences, but primarily they're very similar in that they will have a way to you know, create a smoother STL through various options and methods. And so, if we look at this example from SolidWorks, we would try to save the file. We would choose STL. The box on the left has a circle around options. If we pick those options, it brings up another dialog box that shows us a lot of different options that we can use to create a better STL. Now, in Inventor and SolidWorks and a lot of parametric solid modelers, we also have the ability, if we go into the options part of STL creation, to use assemblies. And so we can create an STL of an assembly, and that is only available to us most of the time anyway. Never say never, but it's only available to us in the options area of these softwares. The options dialog box has a lot of different lot of different commands, and sometimes we don't understand them all fully. In the lower right-hand corner, you see help. You hit your help, you'll get a complete and full explanation in SolidWorks, say, for example, of how to use those options and what they're all about. Here is another slide where we're looking at the similar dialog boxes in Inventor, just to make a point that it's very similar across software packages. So now, there, like we talked about, there are different file formats. We've used object files in the past with success, but the STL is by far the best that we have found. Another option, and it's being increasingly used, is Fusion 360. Now, Fusion 360 handles STLs a little bit differently. It sort of ignores the translation of the solid into an STL, choosing to export the solid directly into the slicing software. So, it is basically creating an STL format, but you don't get the same options that you would in another software. You'll smooth your model and work it in Fusion 360, and then export it directly into your slicing software. And I think that's all I have. I'm going to give you my contact information here. And it is, as you can see, it's I've given you my email address. Please feel free to email me with any questions that you have. If I can help you further understand proper creation of STLs and how to prepare your drawing for or your model for 3D printing, I will be happy to do that.